Okay, so last time we talked about how it was possible for us to technically use linear regression as a classification tool, where we considered if you get a negative number out of your logistic regression, then you say no. And if you get a positive number, then you say yes. In practice, this is almost, I guess, what we do. I want to get it more. I want to make this more concrete by explaining to you something called the sigmoid function. So I hope I don't write this wrong. So basically, the sigmoid function is just a normal, function that you would see, let's say, in algebra class. I think this should be correct. But basically, what this does is if you plot this out on Desmos or whatever graphing calculator have you, what you'll see is x and f of x. What this will give you is I want to actually bring this over here. So it goes over there to negative infinity and then positive infinity. And let's say that this is 1. So now what this graph will look like is something like that. It's almost like a sideways S kind of. And by the way, this is 0 over here. I just want to make it clear. So what is this? What is happening here? I want to take a step back and figure out what's happening here. First of all, I want you to notice that there is an asymptote at 1. So here, this is an asymptote. And then at 0, this is an asymptote. And basically what that means is that no matter how far you go to the right, you'll never reach 1. You'll get closer and closer, but you'll never reach 1. And no matter how far you go to the left, you'll never reach 0. You'll just keep on going closer and closer to 0. Okay, so it effectively, what does this do? Let's say, I want to do something. Let's say that, okay, so this was linear regression, right? Linear regression. This was y equals mx plus b. Okay, logistic regression. I know it's called I know it's called regression, logistic regression. That's a misleading name because it's actually used for classification. So I want to put it in parentheses that this is actually a classification problem. Classification problem. So linear regression was y equals mx plus b, but logistic regression is y equals let's say we call this not f, but we call this sigma. Okay, because for sigmoid kind of, right? Sigma of mx plus b. Okay, what have we done here? Well, what we've done is we've taken our linear regression and we've transformed this into a classification problem. And how is that, you may ask? Well, if you think about the sigmoid function, which we introduced up here, so this is actually the sigmoid function now. So the sigmoid function, what is its domain? So the domain meaning all possible x values, all possible inputs to this function. Well, it's negative infinity to positive infinity, right? So technically it takes care of any possible linear regression task, right? Any output from linear regression could be fed as an input to this function because it's negative infinity to positive infinity, right? You can take anything from the left side to the right side. And what is the range? Range meaning all possible outputs. Well, you can get anything from 0 to 1, inclusive. Sorry, not inclusive, including everything in the middle of 0 and 1. So you don't include 0 because you'll never reach 0 and you'll never reach 1, but everything in the middle, be it 0.6667 or 0.0001, every single thing between 0 and 1 is achievable. And effectively, what does this do? So let's say that we apply this to our rain example, right? Is it going to rain? So rain, is it going to rain? Well, let's say outputs, our linear regression outputs 5, right? And so let's say 5 is right over here, right? And so we go and, uh, so our linear regression, 5 is basically, how do we get this? We did mx plus b. Whatever our x value was, whatever m and b are, we're assuming that m and b are given to us, and we're taking a new example, x. And that has given us 5 somehow. So now we can go here and feed that into the sigmoid function. So we can find sigmoid of 5. And let's say, I'm making this up, but let's say it is something like 0.92, right? It's close enough. It's like close to 1. It'll be close to 1, but I don't know if it'll be 0.92 or something else, right? But it'll be like something close to 1. It'll be definitely be above 0.5, right? And so let's say if the result of all of this computation is greater than or equal to 0.5, then yes, there will be rain. If the otherwise, no, it will not rain. That's our prediction. This is how we'll come up with our prediction. And so in this case, the output that we've gotten is more than 0.5, and therefore we predict that yes, it will rain, right? And I want to bring to your attention that what did we do here? We actually did mx plus b. We got 5 out of this, and then we applied sigmoid to the result. Okay, and since the range of this function, since the range of all possible outputs of this function lie between 0 and 1, we can view this as a probability. What am I talking about? Over here, 0.92 isn't just more than 0.5. We're saying that it's a 92% chance of rain tomorrow. So we can tell you more than whether or not we think it's going to rain tomorrow. We can tell you the actual percentage chance that we think it's going to rain tomorrow. And that is 92% based on our calculations. So sigma of mx plus b actually gives us a probability of something happening. In this example, whether or not rainfall is going to happen tomorrow. And let's say that the output of all of this stuff was not 0.92, but it was actually 0.37, right? And in that case, based on this rule, we would say that the result is actually not greater than or equal to 0.5, so it's no, right? 0.37 is not greater than 0.5, so no. So we think that no, it's not going to rain tomorrow, but think about it in a more logical way. We're saying that there's a 37% chance of rain tomorrow, which means that it's less than 50% chance of rain tomorrow, which means that it's likely that it's not going to rain tomorrow, right? 37% chance for rain means that we think it's not going to rain tomorrow, right? Does that make sense? And if it's a 50% chance of rain tomorrow, that means that we don't actually know whether or not it's going to rain tomorrow, then the choice becomes arbitrary. Here we've arbitrarily chosen that if the result is actually 0.5, we'll say that it will rain tomorrow. But we could have also said no. We could have also changed this threshold from 0.5 to, let's say, 0.3. And there are applications in which you would want to do that, even though it doesn't make too much sense right now. And so I hope everything here is sort of clear. And I just wanted the takeaway from this video to be that we did linear regression. Linear regression was a way of getting a continuous output from negative infinity to positive infinity. And we wanted to use linear regression to be able to do a classification task, but we couldn't. So what we had to do was we had to alter it a little bit by adding on this thing called the sigmoid function, which outputs a probability of something happening, and therefore we can make an informed decision based on that. So thank you for watching this time.